Okay, now some of these you probably wouldn't have been able to do without a calculator, but I just want you to see no matter what the number is. Okay, we know what 4 to the third power is. We know what that means. 4 times 4 times 4, right? So 4 times 4 is 16, times 4 is 64. 4 to the negative third means 1 over 4 to the third. Anything to the 0 is 1. If I raise 4 to a fraction, then the bottom number tells me what the root is. So since the bottom number is 2, it's square root of 4 to the third. And it doesn't matter how you evaluate that, guys. You can take the square root of 4 first, and then that, which is 2, and then 2 to the third is 8. Or you can take 4 to the third first. 4 to the third is 64. Square root of that is 8. Either way, 4 to the 3/2 power is 8. And 4 to the first power is just 4. Okay, so if we look at a bigger number, 27. 27 to the second power, 27 times 27 is 729. Well, 27 to the negative of that power is 1 over 27 squared. Just like 4 to the negative third was 1 over 4 to the third. 27 to the 0 is 1. Anything to the 0 is 1. When I take 27 to a fraction, then the denominator tells me what the root is. So it's cubed root of 27 squared. And again, it doesn't matter the order. I'm going to take the cubed root of 27 first. The cubed root of 27 is 3. And then 3 squared is 9. Or you could have taken 27 squared first and gotten 729. And the cubed root of 729 is 9. Either way, you get 9. And 27 to the first is 27, just like 4 to the first is 4. Okay, so just how exponents work, whether it's positive, negative, 0, or a fraction. Okay, if I have a fraction raised to the fourth, I multiply 1/2 times 1/2 times 1/2 times 1/2, just like anything else. Okay, and so then I'm going to get 1/16. If I raise a half to the negative fourth, then I end up taking 1 over 1/16. I end up getting 16. Okay, just like above it, when I had 27 to the second was 729, and 27 to the negative second was 1 over that. Well, here 1/2 to the fourth was 1/16, so 1/2 to the negative fourth is 1 over 1/16, or 16. A half to the 0 is 1. This is asking me to find the cubed root of a half. Well, I'm not going to do that. Okay, that's going to be some irrational number. I'll put that in my calculator and figure that out. I don't know what times what is a half. It's a irrational number. A half to the first is a half. E squared is E times E. And so on my calculator, of course, I wouldn't get a rational number since E is irrational. If I take E times E, I get about 7.389056099. E to the negative 1 is 1 over E, and E to the 0 is 1. Okay, just a little bit. Just be careful with these, numbers that you're raising to exponents. There are some patterns here that are the same. Okay, so we're going to look at these functions. F of x equals 2 to the x, g of x equals 3 to the x minus 2 power, h of x is a fourth to the x, and m of x is e to the x. We're going to do functions just like, just like we did in chapter 2. If they ask me for f of negative 3, that means stick negative 3 in for x in the f function. It's going to be 2 to the negative 3. F of negative 3 is 1/8. G of 2 means stick 2 in for x in the g function. That's going to be 3 to the 2 minus 2, 3 to the 0, which is 1. H of negative 1 means stick negative 1 in for x in the h function. 1/4 to the negative 1 is 1 over 1/4, which is 4. m of negative 2 is e to the negative 2, or we could think of that as 1 over e squared. Okay, so please don't get confused. We're going to be talking about these as functions and expecting you to do the same types of things we did with the other functions. Again, when you solve these, we did these a little bit in the previous video. 2 to the x equals 32. Well, I'd like to write 32 as 2 to a power. I might have to fool with that on my calculator if I'm not sure, but it's actually 2 to the 5th. So then once you have it in the same base, you can drop the bases and just say, okay, x is 5. Now, if it's 32 to the x, I still am going to write 32 as 2 to the 5th to the x, right? That's another way to think of this. 2 to the 5th to the x. Well, when I take a power to a power, I multiply those exponents. So this is 2 to the 5x equals 2. So just like we did up here, we can, now that I have the bases the same, I can drop them. So I'll say 5x equals, what is that exponent? 1, right? 5x equals 1. So x is a 5th. Would be my answer to that. Okay, back up here to the other problem. 2/3 to what? Well, 2/3 to what power? I'm going to kind of rewrite this. I know I can write 27 as 3 to the 3rd. I can write 8 as 2 to the 3rd. So I have here 2/3 to the x power equals 3/2 cubed, right? Since these are both, this is 3 to the 3rd, this is 2 to the 3rd. 3/2 to the 3rd would be 27/8. They're so close to the same base, but just not quite there. So I'm going to write 2/3 to the x equals, if I write this as 2/3, then I just switch the 3 to -3. So x is -3. 3 to the 2x equals 81. Well, let's see. 3 to the 2x. 81 is 9 squared, but that doesn't help. But I could write, oh, it's also 3 to the 4th, right? If it's 9 squared, 9 is 3 squared. So 3 times 3 times 3 times 3 is 81. So now that I have it in the same base, I can write 2x equals 4, x equals 2. And that makes sense. 3 to the 2 times 2. 3 to the 4th is 81. Okay. All right, then we're going to go the other way around here. H of x equals 16. Well, let me see what h of x is. It's 1/4 to the x. So they're saying 1/4 to what power equals 16. I think I'm going to, instead of saying 1/4, I'm going to say 4. And so that means, 1/4 to the x is the same as 4 to the -x. I know 16 is 4 squared. So -x equals 2. So x would be -2. 1/4 to the -2 will give me 16. And m of x equals 1 over e. M of x is e to the x. So I'm going to say e to the x equals 1 over e. Well, that would have to be -1. Okay, so it's just plugging in what m of x is and setting it equal to whatever it asks you to. All right, so I would like you to do this homework out of the book if you could. Page 350, 10 to 32 even, and 64 to 96 even. I know that's a lot. Let's see. I think I'm gonna maybe have a quizzes for you or something. But other than that, just do these evens out of the book and look for them posted by the end of the week, and then are the answers. I'm sorry, so that you can check them, and we'll go over these, of course, when I see you in class. All right. Have a great week, guys. Bye.